Hi, now I want to solve a problem uh, which is printing the elements of an array in the decreasing frequency. If two elements have the same frequency, then print the element which came first. So the meaning of this problem is we have to just print the array in the decreasing order of the frequency, not the decreasing order of the elements. So, what do you mean by that? So, it means that we have to find out how many times a particular number is repeated, and then based on that frequency, we have to sort the array and then we have to print the array, and we have to make sure the order in which the elements are in the array shouldn't be changed. Like if two elements have the same frequency, right? So um, like in this case, let's take an example and go in detail. Like we have two. So now two is occurred one time. Next element is 5, which occurred one time. Again we have 2, uh, which occurred 2 times. Now we have 8, which is occurred one time. 5 two times. 6 one time. And we have 8, which has occurred 3 times. So so where if you see here, 2 and 5 have the same frequency, but at the time of printing, we have to print 2 first and then 5, because uh, if you see the array, 2 has the least index compared to 5. 0 is less than 1, so 2 comes first. So 2 should be displayed first when compared to 5. So the order in which this should be displayed is basically 8, 8, 8, 2, 2, 5, 5, 6. Because 8 occurred 3 times, that is the topmost one, or the firstmost element that needs to be printed, not because of the number. If this is a number 1 which occurred 3 times, then it would be number 1. It's entirely based on the frequency. So right now we have it as 8, so we will display that as 8. And because 2 came first, we will print 2 and then 5 and then 6. So this is how our output should be. To implement this problem in a more efficient way, like we have to use hash map, because to access a particular key in a hash map, uh, the complexity is O of 1. So we can easily access a key in the hash map. That is the reason we are going with hash map when compared to a two-dimensional array, because in an array we have to traverse the entire array and search for that particular key. So so we, we uh, so I prefer hash map in this scenario. um, Let me explain the solution, because the implementation is so big, it didn't fit in the whiteboard. I'll copy the entire code in the description of the video, and then now here I'll explain the actual logic how this is done. Um, so so the first step in solving the problem is we have to construct a hash map with keys as the indexes and the values as the frequency. So like how we did it here, the same way. Like but instead of storing the actual numbers, we will store the index of its first occurrence. So when to start with, 2 is at the index 0 and it has occurred one time. Next, 5 is at the index 1 and it occurred one time. Now again 2 has come. We will check the hash map how much ever the hash map is built, we'll check the entire hash map if we have that key already. Because we didn't store the key directly, we have to access the key using this index. So we have to loop through the entire hash map, like we have to check what is there in array of 0. Array of 0 is 2, whether that is equal to this 2, or if array of 1 is equal to 2. Like, that's how we have to check in loop every time you want to increment the frequency or add a new element. We have to check in the hash map whether that key already exists. So it's a roundabout process, as we are storing index instead of key, instead of the actual numbers. So so now, to for our easy understanding, I'll write numbers here, so we'll know how it's done. Because 2 is already there, I'll change the frequency to 2. And we have 8 at index 3, and it has occurred once. And we have 5, because 5 is already there, I'll just increment the frequency. And 6, we have 6 at index 5, and it has occurred once. And 8 at index 2, and again 8, so it has occurred 3 times. So this is my hash map. This is how I construct my hash map. The reason why I'm storing indexes instead of the actual numbers is, if I store numbers, I might get the output something like 8 8 8 5 5 2 2 6, meaning the order in which the elements have arrived is might not be preserved if there is same frequency. So if we have index, we are keeping track of the starting point of that element, I mean the starting index of that element. So so we can maintain the order in which they have come if we have the matching frequency. So once we construct the hash map, what we have to do is we have to sort based on this frequency. Again, there are two parts to this sorting. We will sort in a descending order, and after sorting, if two frequencies are same, then I'll go check the indexes, and based on the indexes, I'll sort the total hash map. So how am I going to do this? So first, like, I've written the comparator of my own comparator, because the default ones doesn't check for the extra additional thing that I've just told you, told that it doesn't check for indexes. So this is the comparator class I've written. So where I'm implementing this comparator of type hash map, which takes two integers. Okay, and inside the comparator class we have a compare method. This is a built-in method, but because we have to write our own logic, we have to include this at the rate this override annotation. So this tells us that don't use the default or the built-in implementation for the compare method. Use the what implementation the user is giving. Whenever you use override, that's what it means. And in the even in the compare, I'm taking two entries, I mean two elements from the hash map, and I'm comparing the values. So what I'm trying to do is, because I want it in a decreasing order, so I'm comparing the second element and the first element. If I do first element and the second element, then I'll get it in a ascending order, but we want it in a descending order. So I'll compare object 2 dot get value. So whatever the entry that I'm getting here, that means I have my entry, meaning one entry is 0 2, the other entry is 1 2, the next one is 3 3, next one is 5 1. One entry comprises of a key value pair, like both are integers. Okay, so my first entry, it means O1, my second entry means O2. So when I compare these two values, right, so my each in my O1 will have a key and a value, and my O2 will have a key and a value. So I'll compare the values of O1 and O2, and if they both are same, they are not greater or less, that then it enters the else condition, where it will check the key. My key is the index, so it will check. Now I want to print it in an ascending order, because the frequency of an element which if two elements have the same frequency, then I'll have to go check the index which came first means ascending. So I'm using object 1 dot get key is greater than object 2. This will you know um, um, sort this in ascending order. Okay, so so this is how it will actually sort the entire hash map, and it will the resultant hash map after sorting will be 33021251. Because these two have the same one, it has to do in ascending order, so 0 comes first and then 1. Okay, so this is our resulting hash map. When we have this hash map ready, what we are going to do is we are going to print them back to the array, or print them as is. So when we take this index, for example the first entry, so what we are trying to do is we will get whatever element it is there at the index 3, and I'll print it 3 times. So, and I'll take the index 0 and I'll print the element in the index 0 two times, and I'll take the index 1 and print the element at index 1 two times. Same as like it goes on with the entire hash map. So this is how I'm going to preserve the order as well as sort in a descending order of the frequency. So this is how it's actually done. But when you look at the complexity of this solution, first we are trying to construct the hash map. For constructing the hash map, we will need, because we are traversing the entire array, so it is O of n, where n is the number of elements or the size of the array. And then we have to sort the hash map based on the frequencies. We know that any efficient sorting would take n log n complexity, where n is the number of elements. And because we are sorting the hash map which is already constructed, and if you have noticed, hash map only has unique elements. Okay, so that means that sorting, the time taken to sort that particular hash map will be less um, when compared to the size of the array. So it will be, if the size of the hash map is m, so my complexity is m log m to sort the hash map. Okay, and then I have to add them back to the array. So when I add them back to the array, I again, because there are n elements, so I'll again take O of n complexity. To sum it up, it will be O of n plus O of m log m complexity. This is the complexity time. This is the time complexity. But because we are already using hash map, and we are not using any extra array, we are just using a hash map. So because we are using hash map, we have a space complexity as O of m, number of distinct elements present in the hash map, that is m. So this is how this particular problem is solved. Thank you.